In this video, we're going to look at the data together, and the data we're going to look at is going to be retrieval metrics related. So I have a series of blog posts around evaluating and indexing different data sets with the RAGatouille library. So if you go to my blog, and then if you click on information retrieval, then you can see I have 18 posts so far on a number of topics. The one that I'm interested in today is this blog post I did a while back where I was evaluating the DAPR ConditionalQA dataset with RAGatouille. And the DAPR dataset is the document-aware passage retrieval dataset. If we go to that on Hugging Face, we can see that they have conditional QA, Genomics, Miracle, MS Marco, natural questions. And for each one of these datasets, they have a corpus, they have the documents, they have the QRELs, which I think stands for like query relationships. So query passage relationships, and then they have the queries themselves. Now, I started with conditional QA because it's the smallest one. There's only 70,000 rows. So it indexes pretty quickly in RAGatouille. And I'm using Jarvis Labs AI, and I'm using a RTX 6080A to do all of these indexing operations and search operations. And before I move on to some of these larger data sets, so Genomics is 12.6 million, Miracle is 32.9 million, MS Marco is 6 million, natural questions is 3 million almost. I want to make sure that I'm evaluating the metrics correctly. And the best way to do that, in my opinion, is to take some time and look at the data. Look at the results of the search, look at the scores, and look at what is expected. So what's in the expected set or list of passages for a given query, and what does that text look like, and did we retrieve that text correctly? So that's going to be the focus of this video. Usually most of my videos are more prepared, where I have a notebook and I just walk through the notebook. This one's going to be more organic. I have a general sense of what I'm trying to achieve, but I haven't sorted out all the code yet. I just kind of have the basic things loaded. So just a heads up that this is going to be a bit more wandering than usual, but yeah, I think that'll still be pretty fun. And I think we should open up Claude because we will definitely need to reference Claude at some point in this process, and I'll have extended thinking and concise, which is usually the parameters I use for coding stuff. So I've installed datasets. I'm importing Pickle, and I'm importing load dataset. Then I'm loading the conditional QA related datasets. So I have passages, queries, and the QRELs. Then I did the indexing in Jarvis Labs, but I didn't want to analyze in Jarvis Labs because, you know, here I have two sessions. That's why this is 2.16, but you know, this is just using a fraction of a compute unit per hour, whereas Jarvis Labs RTX 6000 ADA is $1 an hour, so obviously a lot more pricey. So let me walk through the code that I used in Jarvis Labs, and then I'll show you my notebook again, and we'll kind of work through it together. So the indexing itself is very easy thanks to RAG. You just pass the index name, the text that you want, and passage IDs. It took, I don't know, 5-6 minutes, maybe 10 minutes. I don't know. It was very quick. And then I give it my query. I give it how many responses I want, and I get back a list of dictionaries where I have content, score, rank, document ID, passage ID. I'm going to structure the QRELs in this way because that's what the PyTrek evaluator uses, and that's what they showed in the dataset card example on Hugging Face. And we're going to do the same thing in our notebook. So what we end up with is that for a given QID, so dev5 is the Q, we have multiple passages that have a score of 1. And then we iterate through our queries, we get our results, and then we add our results to the PyTrek results dictionary. And so now we have, for this given QID, we have this result document ID, and then we have the results score RAGatouille calculated. We then use an evaluator with a PyTrek eval. We pass it our results, and we get back our metrics. And it shows that, okay, for this QID, for dev5, the recall metric, which we specified here, is 1 out of 6. So that was one method. So what I've done is this metrics and PyTrek results that I exported as pickle objects, and I've loaded them in here. So let's take a look at this, just to get familiar with some of the baseline data. So here's QREL's rows. So dev0 is answered by passage ID 8641. Dev1 is answered by 8910. Dev2 has 3 passages related to it. Dev3, here's the first passage, and so on. So we're going to run this little operation where now, if I look at Dev2, for example, we should see that we have 3 relevant queries or relevant passages. So for example, just going back here, Dev5 has 61 1, 4, 5, 17, 37, and 39. So if I say dev5, 61, 1, 4, 5, 17, 37, 39. So far so good. So that's what QREL's rows looks like, and that's what our QREL's dictionary looks like. If we look at queries ID, here we have up to dev 284. So let's see, if I want to take a look at one of the queries. So we have ID and text. How would we do this? So let's do, it's going to be not pretty, but if we say if QID equals dev5, then print Q text. Okay, so I work for a large company as an employee, and I've recently experienced a stillbirth at 30 weeks pregnant. I would like my live-in partner to have some leave support for me. Can my partner take leave from work due to my stillbirth, even though he is not the biological parent of the child? Okay, so that's how we can take a look at our queries. If we look at 2, I'm a guardian to a 16-year-old teenage boy from Syria whom I cared for when he was young and homeless. I want to change his surname to mine. Can I apply to change his surname to mine? So if we go back up here, and we look at QREL's dev2, there's 3 responses, or 3 passages. Okay, so I'm going to look at my passages. And I know there's this method here, but let's do this. Let's see. Here's queries. And let's take a screenshot again so it doesn't have that tooltip. And let's say I want to find a dataset item where one of the fields has a specific value. So if I give an example, I want to find where passages is 86. For example, I want to find where passages has an ID of 86-4. I've done a for loop example, but that seems less than ideal. How do I search a Hugging Face dataset in this way? Okay, so we can do filter, lambda example is this. We can use where, if your dataset's version supports it. We can convert to pandas data frame, especially for a passage dataset with 70,000 rows. Okay, so I have a feeling I might want to go to the datasets option, but for now, let's look at this. And let's take a look at text. Okay, so here's 86-4, -5, and -9. So I wonder if we can do this. And we can. So there's 3 passages. You'll need to get the consent of everyone who has parental responsibility for the child before you make some important decisions. For example, then we have changing the child's surname. Then we have, if you cannot get consent, you can ask the court to decide, use the form, make an application in existing court proceedings related to children. So this is our query. I'm a guardian. I want to change the surname of the 16-year-old teenage boy. And then here are the 3 documents, or passages rather, that correspond to this. Okay, so this makes sense, and I'm starting to recollect how this is structured. So we looked at passages, we looked at queries, and we took advantage of QREL's rows. So I think we have a general sense of what everything looks like. So let's take a look at the metrics. And so metrics is very straightforward. It has the query name, or the ID, and then it has a dictionary where the key is the name of the metric and the value is the value of the metric. So this makes our searching pretty efficient. So if I do metrics dev2, I get recall. If I do metrics dev2 recall, here's the value. And then here is PyTrek results, where this is going to give us the passages that were retrieved by RAGatouille and the RAGatouille score, which is the plaid score in this case. So if we go back to PyTrek results, we got the results from rag.search. We use as the key value the ID of the query, Q in queries. And then we have a dictionary where we have document ID and score for each of the 10 results, or up to 10 results. And just to go back to our RAGatouille output, here is document ID. A little bit of a confusing part is they also have a passage ID, but that passage ID is more of like an internal RAGatouille passage ID, which is like, think of it as like the index passage. So this is the 960th passage, or I guess 961st passage. Whereas document ID, if I understand correctly, is this collection that we gave it, this list of passage IDs that we gave it, and these passage IDs were the underscore ID in the passages dataset. So we're interested in this document ID, even though DAPR has its own, I don't think I've loaded it here, but DAPR has its own documents dataset. So if we go back here, this is our RAGatouille document ID, but our passage ID, and this is the score that RAGatouille gave it. For our intents and purposes in this video, we don't care about the RAGatouille score. If you're interested in how that score is calculated, the best way to learn about it is to read the PLAD paper. But if you're interested in a video or a blog post, I have a video and blog post on the PLAD scoring pipeline. One of the cooler things I've done is understand that scoring pipeline. So I had a lot of fun with that, so check that one out. So if we look at PyTrek results and we look at Dev2, we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there were indeed 10 passages that it retrieved, and these were the passage IDs that it retrieved. So we can kind of put this together now, right? So we know that for Dev2, the relevant passages are 86-4, 5, and 9. So if we go down here, we see 86. Do we see any of them? No, we don't. And that's why our recall was 0. So none of our 3 relevant passages were retrieved in the top 10. So the recall at 10 is 0 because 0 out of 10, 0 passages were retrieved out of the 10. So at this point, I feel good about, number one, I understand the relationships between these 3 related data sets. So that's good. Number 2, I can connect that information with the RAGatouille search results and come at the conclusion of what the metrics should be, because I love recall. It's my favorite metric because it's just straightforward, makes sense, easily verifiable, as opposed to something like NDCG, which I think is the full acronym if I'm remembering correctly. Even mean reciprocal rank, is a little more involved. Recall, really nice, intuitive, easy to validate metric. So definitely my go-to when I want to iterate quickly. All right, so that's great. This is like version 0. We have a basic understanding of how everything works. But I still would like to do something more interesting than this, in the sense that, or not necessarily interesting. It is more interesting, but it would be more powerful. Is that I want to do this for multiple values. So what I'm going to do is I'm going to kind of utilize the power of Jupyter Notebooks, where we have this run button, and every time you press the run button, it runs the cell again and again. So something that I like to do, which I want to attempt to do here, and I think it'll work out, is I want to use iterators to quickly visualize what's going on. So the thing I want to iterate through is I want to iterate through all of my queries. And if we look at so there's 271 queries, where I'm not going to go through all 271, but you can do 271, right? Like that, you can take whatever, 20, 30 minutes, maybe an hour. You can go through the whole thing, manually validate this. And that's something I do for retrieval when I have, something like a few hundred. I'll even go up to like 2,000. Worst case, if it's like binary classification style scoring. But for even more involved kind of paragraph results, if it's a couple hundred, you can take a couple hours and you can go through it, manually calculate it. Yeah, it's kind of annoying and it's a little tedious, but man, like after you do that, your calculations are correct. Your code is correct. Now you can scale up, right? And now you can try other things with the confidence. And I think having that certainty and having that confidence is worth the couple hours of investment into looking at the data and manually calculating things. Okay, so what I'm going to do is I'm going to grab the ID and it's a list, which is perfect. So I'm just going to call this IT, and I'm going to make it an iterator. And then what I'm going to do, just as an example, is I'm just going to do next, and I'm going to pass it the iterator. And we can see that because we have this Jupyter Notebook interface of running the same cell, it's going to run next, and then it's going to go through each of our values. And I just remembered that I usually zoom in, so apologies for not zooming in earlier. If at any point I change some code, I just refresh the iterator, and we start back at the top. So this pattern of creating an iterator in one cell and then running next in another cell, I use that almost every time I want to look at some data in a Jupyter Notebook. So that's step one. So I got my query ID, and I need that for everything else. So it would be nice to see the text. So the next thing I like to do is I like to make a custom print function, and it's going to take the query ID, and I'm going to print, and now here I'll use this business. So we'll see how, like, I don't, it has this filter every time, so that'll be kind of annoying. But so this is not passages. What I want to do is I want to see the query text. So queries, example ID equals QID, and show me the text. So now so let me refresh my iterator. I'm just going to pass this value as QID, and then I'm going to print. So hopefully this does that. Now you'll see, like, yeah, here we go. So I think it's working. Not fun to see that filter every single time, but we'll see if we get to that point of refining this. I also want to print the QID because I am familiar with some of them now. So let's run this again. So here's dev 0, here's dev 1, here's dev 2. Now, instead of having this list, let's see if we can just grab the first item. All right, and here's that dev 2 that we looked at, and then, yeah, here's that dev 5. So far looks good. If we wanted to, we could add this in. We could add in some formatted text. And then this would be text. And let's just say QID. We'll just imagine that this filter bar is separator between QID and text. All right, so this is step one. The next thing we want to do is we want to grab, we want to get all of our passages that are relevant to that. So how would we do that? So QRELs, I think here's where QRELs comes into play. So if we look at the keys of QRELs, I guess can we go like this? No attribute list. Is there a to list? No. Let's go list. Okay. So we do something like this. So that's going to give us the passage IDs, and then we have this logic here where we're filtering our passages for that. So let's dump this here. We'll call it passage IDs, and we're going to give it QID. And then for our first iteration, we'll just print this whole thing as is. Except now we're looking at passages in PIDs. Okay, so let's look at dev2, which we know. You'll need to get the consent, changing the child's surname. If you cannot get consent, use this form. Okay, so looks good. Running out of variable names that are short, so we're just going to call this passages, Ps. And then we're going to say for P in Ps, print P. And here we go. We can see, let's close this. We can see the three passages. So we see the query ID, we can see the text of the query, and we can see the passages. And if we wanted to say, passage text, the filter is really getting in the way now, but I think that's fine. We'll get to that eventually. And if we look at some of these, adopting our would-be daughter, man, all of these are traumatic, so I apologize. Bereavement leave. Yeah, so let's try to find something that's not so traumatic. Okay, my goodness. Okay, it's a little better. I inherited 40,000 pounds. Do I have to pay inheritance tax on my windfall? Usually you don't pay tax on anything you inherit at the time you inherit. The estate of the person usually pays the inherit tax. Most cases you don't pay the inherent tax. So okay, looks good, right? So another sanity check. And ultimately that's what this tool is for, right? It just gives us a lot of certainty that what we're working with makes sense. Okay, so that's step one, or kind of data viewer type A, where I'm not really looking at the results yet. I'm just kind of visualizing the data that I have. What we should do now is we should try to incorporate the results. So the metrics is here. So let's get that in the mix. So and I know it's recall at 10, so I'll use that. And we'll make that a formatted string. And so we get metrics, QID, recall 10. So let's just grab this. All right, that's good. Let's print a divider line. So that looks good. All right, so metrics is not really useful without context. So what I want to get now is I want to get the PyTrek results. So we'll call this results. And what do I want to do? I'm going to get the passages from these results much in the same way we did earlier. So I'm going to use this list from my dictionary keys, and just to make sure that's what I want to do, we'll test it out here. And yes, that is what I want to do. And then we'll grab this and we'll say, let's call this result PIDs. All right. And then let's keep this divider line here, even though we'll get our divider with the filter. And we'll say for P in P's res, print P. Okay, so we can kind of take a look now, and we can see the recall was 100%. The text here was, you may be able to get funding from the Adoption Support Fund, and it looks like we have this one here. Now, something that's common, at least, well, I don't know if it's common, but I think it's definitely something you'll come across, is you'll have similar looking texts. So I think in addition to having the passage itself, I think we should also get the PID. So what that's going to look like is, let's zip together our passages and our PIDs. So passage ID, and we're going to do formatted string. We're going to say I, and then P. Let's see if that works. Cool. So here we have this. Here's our, and we can do a quick sanity check. Well, let's actually just do our dev2 and dev5 and a couple of the other ones that we've already seen. So dev0. So here's 86459. Here's 61 145 17 37 39. Don't really need this print passage text, so we'll just print an empty string so we get a little breathing room. Okay, and let's do the same thing down here. So we have P's res, and what's going on? I messed something up. Okay, let's just call this res. We're going to zip together P's res and our PIDs. And now we're going to do for P, comma I in res, we're going to print this. Okay, so this makes it a little easier. So we can see our recall is 0.4, so we got 4 out of 10. So we got 50-1, we got 50-16 is not there, 50-22, so that's 2. 50-23 is not there, and 50-47 is not there. So what's going on? How did we get this? All right, so this is dev8. So let's look at this. Let's look at dev8. So let's do this. Let's say QID equals dev8. So 1, 16, 22, 23, 47. 1, 16, 22, 23, 47. So that part is correct. Let's look at this. 0.4 is correct. And we have 1, 22, 122. Yeah. So I don't know how is this what is going on? So let's look at QID. This is where I wish we had this was a stream so you all could talk to me. 1, 16, 22, 23, 47. 1, 22. Yeah, so I'm only seeing 2. So I don't know why it's 0.4. 2 out of 10 should be 0.2. Just to make sure, let's look at this one here. This was dev 8. No, that's not going to look good. Let's try this. Okay, so this is QRELs, rows, and QRELs rows, and what are we looking for? Query ID. Dev 8. And corpus ID. 1, 16, 22, 23, 47. Yeah, so I'm stumped on this because only 2 of them show up in the results. So why is the recall 0.4? I'm almost tempted to run search on this. Let's see what it looks like for some of these other ones. Okay, recall is 0.25, 85-1. Nope. 85-7. Nope. 85-13. 85-15. Here we go. Oh my gosh. I know what I'm doing wrong. Oh my gosh. Viewers, I am so sorry. I was thinking of recall in the wrong way. This is a little embarrassing. But we got 1 out of 4. So 1 out of 4 is 0.25. Okay. All right. Let's go back from the start. Let's look at dev 8 again. Oh my gosh. Help me. So here's dev 0, dev 1, dev 2, dev 3, dev 4, dev 5, dev 8. Okay, so let's go back here. So 50-1 is 1 out of 5 so far. 50-16, 50-22 is 2 out of 5. So there we go. We have 2 out of 5 passages are in the top 10. So our recall is 2/5, which is 0.4. I was, for whatever reason, thinking that 4 out of 10 is the recall. That's not where recall is. That's not a metric that I'm aware of. Maybe mean reciprocal rank kind of is related to that, like if the 4 were in the top 10, but not really, because then you have to look at the actual rank. So anyways, I just had a mind fart, so I'm glad we're back to normal. Okay, So let's look at a couple more. Let's look at, this one is 0.25. We already saw that. Here's 0. So we have 44. So here's 44-1, but that's not in there. 44-40 is not one of the answers. 44-25 is not one of the answers. Let's do a couple more. 89-22 is there. So we have 100% recall because we have 1 out of 1 in the top 10. Let's see. Oh, our filter went away for whatever reason. This is, what is that, 2/7? 2 out of 7? 1, 2, 3, 4, 5, 6, 7. So we have 92-40, that's 1. Then we have 92-42, that's 2. So that should be the 2. 48 is not in there, and none of these other ones are 92. So this is basically how I, will validate something like this. I would probably go a little further and add something that will keep a score. So I could make a little Gradio app. That's something that an idea I stole from one of Jono Whitaker's videos, and I think I have a blog post on it. Let's see, grading all the responses. Yeah, so let's see if I can zoom in. So this is one way that I made a little app in Gradio. Again, I took like most of the code, 99% of the code from Jono's video and just made it for mine. But basically here I was evaluating, I was prompting models, looking at its answer, looking at its reasoning. If I hit correct, it would save, what would it save? If I hit correct, if choice equals correct, is correct is 1. Otherwise, I think I initialized this data frame with is correct is 0. And so that's is correct is 0 there. So this, this is one way we could also take a look at this, is that we could make a little Gradio app, we could make a little fast HTML app, and probably something I'll do in a future video, because once I get deeper and deeper into retrieval analysis, I think at some point I might want to do like thorough manual scoring and tracking. But yeah, that's one example of an app that you can make, a quick little data viewer where it has a correct and incorrect button. And then let's say if you had an LLM judge, you could then compare your evaluation with the LLM's evaluation, and then you could find the percentage alignment between you and the LLM as a judge. So that's something that Hamel Hussein talks about a lot in terms of tracking performance as your LLM application evolves. So let's see, I think that's pretty much everything I wanted to do here. I think one last thing we'll look at a little bit is we'll take a look at, oh, filter's back. We'll take a look at kind of the reasonableness of these results. So I'm 71 in a rented accommodation with my 64-year-old civil partner. I have an existing housing benefit claim. Can I continue to claim housing benefits? So the answers, your existing claim will not be affected. We're getting housing benefit, had reached the state pension age. It does not matter if your partner is under state pension age. So this is, again, just another sanity check. Like, okay, yeah, whatever I've done here in this line, I filtered these passages correctly, and I filtered the QRELs correctly because these all make sense to this topic. And then if I look at recall, I can just glance here and I can see that, okay, 54-17, nope, -38, etc. So it did not retrieve any relevant passages. However, if we take a look at what it did retrieve, right, you may be able to continue getting housing benefit or make a claim for the first time if you go to prison or on remand. So that's not part of this query, which is why it's not one of the selected answers. But you can see why RAGatouille, or rather the Answer AI small Colbert V1 model, you can see why it retrieved this, right? It's about housing benefit. housing benefit, partner claiming housing benefit again, claim benefit and housing. So let's see, housing benefit again. Here we have live-in partner, claim, and then you can kind of see, right? These last three, really these like last 4 out of 5, kind of starts deteriorating. You know, the last one has civil partner, which is a match for this concept, but now it's talking about additional state pension, contact the pension service. So you can kind of see why this was the last ranked passage. So again, just another way to get another sanity check in there while you're looking at your retrieval, because well, I think there's 2 reasons for this. Number 1 is obviously, is my code working, right? This lets me know my code is working. But the second thing I found whenever I've done this sort of analysis and more detailed, where I'm like, you know, tracking the score, like correct, incorrect, that I'm evaluating it with, what I found is that by the end of doing this sort of analyses multiple times, I have a much better understanding of the data. I know what the data looks like. I know what these different documents contain. I learn more about the subject matter, right, that I'm working with. So when I start going into automating these things with an LLM as a judge, I have a much better understanding of what the data looks like, and I think that's a really valuable skill to have, and a valuable sense, and you know, kind of common sense to have when you're working with retrieval and search. So I think I will leave it there. In a future video, I will make something that's a little more interactive, like this Gradio app. I'll probably try FastHTM because I haven't made something in it in a minute. But yeah, thanks for sticking around to the end. Again, this is a kind of a new type of video I'm doing where I'm kind of live coding, and you saw some of the hiccups along the way. So if you like this type of video, please leave a comment below. As always, like, subscribe. I'm definitely trying to grow my YouTube channel this year, and I really appreciate the support and how folks are receiving my content. So thank you, and I will see you in the next video.